Good evening, everyone. Yes, good evening, Yashoda and Akash. Let's continue and finish normal distribution today. Is everyone here? If yes, let's start. Okay. Good evening, Vaibhavi. Okay, so yesterday we saw how to convert any normal distribution into a standard normal distribution. How do we do that? If x follows normal distribution with parameters mu and sigma square, then we say that z follows normal distribution with parameters 0, 1 when z is what? X minus mu upon sigma. Hi Yashodan, today it is too much cold today. Ayush, oh, so inter students are giving guest appearance since last 2 days. Suvarna was there, now Ayush is also here. No Ayush, I am not late. Your streaming is 1 minute late. Fine. Okay, let's start. So now we have to see how to look up probabilities from standard normal distribution table. Fine. Now consider Rishuraj as usual is in sleep, is saying good morning. Now let's take an example. X follows normal distribution with parameters mu as 50, 100 as variance. This is what we took yesterday, but there was some problem with internet, so we had to stop, right? So this is mu, this is sigma square, and let's take multiple cases now. First case is, let's say we have to find probability that x is less than or equal to 60. How do we solve it? We first convert it to standard normal distribution. How do we do that? Minus mu upon sigma. Sorry, minus mu upon sigma. So from 60 also we deduct mu, that is 50, upon sigma is 10. Sigma square is 100, that means sigma is 10. Standard deviation is 10. So we'll say that probability, we have to find probability that z, that is the standard normal variable, is less than or equal to 1. 1 will write as 1.00 for the point of for the purpose of table. Now how will we look this up from table? Understand. First, always draw a rough diagram. A standard normal distribution has mu as 0, right? We want probability that it is less than 1. Now obviously 1 will be on the right side of 0, that means 1 will be here somewhere. And we want probability that it is less than 1, that means what? We want this area, right? Now let's see that normal distribution table, what it says. I've downloaded it and rotated it today, so it won't be an issue. First you have to come to this diagram that they have shown above. They have shaded only the region from mean, that is half part, till this region, right? That means, what does that mean? This diagram is going to give us only this area, okay, only this area from mean till 1, not the area on left hand side. But we know this is symmetric, that means this is exactly half, that means this probability is going to be 0.5. So from table we'll have to find out this probability. So let's see how to do that. We have to look up 1.00, 1.00. So go in this x column first, 1.0, and second is also 0, so 0.00. So 1.00, if you add those two you should get 1.00. What is the intersection of that? 0.3413. That means this part will be 0.3413. And if we add, we should get probability as 0.8413. Let me know if everyone has understood this, so that we'll go to next example, because we have to see 5-6 combinations of this. So if you understand this carefully, then we'll go ahead. Let me know if this is clear to everyone. 0.8413. How we looked at it. We'll see another example also. We'll see all the combinations possible in this. Got it? Okay. This was probability that x is for standard normal. This was 1. That means less than positive value. Less than positive value, right? 1 is positive. So it was less than some positive number. Now let's take a case of greater than positive number. Okay, what does it mean? Let's try to find probability that x is greater than equal to. Okay, the data is same, mu is 50, SD is 10. X is greater than equal to maybe 70. 7, not 70. Let's take 72.4. So first we'll have to convert to standard normal. So it will be x minus mu upon sigma, which is greater than equal to 72.4 minus 50 upon 10. So that will give us z is greater than equal to, how much is that? 72.4 minus 50 divided by 10, that is 2.24. So on standard normal graph, now if this is 0, then 2.24 is again on right side because that is again positive. This case we are taking is greater than positive number. Okay. The above case was greater than less than positive number. Fine. So now this is 2.24 and we need greater than, that means we need this area. So how will we do that? We know that total area under this curve has to be 1 because this is a probability curve, right? So what we'll do is we'll find this less than area first, just like we did above, and subtract it from 1. Or in other words, we will write this as, just like Poisson or binomial, we'll write this as 1 minus probability that z is less than equal to 2.24. We'll convert it to 1 minus and then we'll convert it to less than a positive number. So now how to do that? 1 minus. Let's try to find this. So 2.24 we'll have to look up from the table. How will you do that? Let me erase this. So we'll have to say 2.24. That means 2.2 and 0.04. Understand? 2.24 means this and this. Check if their total is 2.24, right? 2.2 and this 4. So their intersection comes to be this 0.4875 if you check. 0.4875. So this will be 0.4875 plus this is 0.5, which is 0.9875. So if we subtract it from 1, we should get 0.0125. That is the final answer. Let me know if everyone has got this. We'll summarize this later, but let me know if everyone has understood this. 0.0125. Correct, Yashodhan, good. 0.0125. Got it, everyone? If yes, let's take next case then, where we'll take less than a negative number. Got it? Okay, good. So less than a negative number means what? Let's take same case, mu is equal to 50, sigma is equal to 10, and let's say we want probability that x is less than equal to, now 25, not 25, let's take 35. That is correct, Akash Misbah. Fine. So now this will become probability that z is less than equal to 35 minus mu upon sigma. So 35 minus 50 divided by 10, which is minus 1.5. Minus 1.5. So from graph point of view, we get this. This is mu is equal to 0. So minus 1.5 will be somewhere here, and we want this area. How do we do that? Understand, this is symmetric, right? So if we have plus 1.5 here, then this red area will be same. Okay, this red area will be same as that white area. So what we can write, how we can write this is, we can write it as probability that z is greater than equal to positive 1.5. right? That is, will change this sign also and will change this sign also. We'll write it as greater than or equal to positive 1.5, and we have already seen how to calculate that positive number, right? So how to do that? 1 minus probability that z is less than or equal to 1.5. That is 1 minus. Now we can look this up from table. 1.5. If we look up 1.5 from table, that gives us 1.5 and 0, 0. That is 0.4332. So that means this area is 0.4332 and plus 0.5, that means 0.9332. So our final answer should be 1 minus 0.9332, which is 0.0668. Check if everyone has got this also. Just a second, let me get some water. I'll be back in a second. Let me know till then if everyone has understood this. Got it everyone? 0.0668. Yes or no? Yes or no? Has everyone got it? Because if yes, then let's go to fourth case, last case. What happened? Isba, Vaibhavi, Akash, Yashodan. Correct, good. Correct. Let's go to last case then, where we want probability that x is greater than or equal to 38. So again, let's convert to standard normal. That means z is greater than or equal to 38 minus 50 upon 10. Okay, Sukarna is also here. Got it? Okay, good. So 38 minus 50 by 10, which is minus 1.2. Again, we'll draw diagram. From diagram point of view, this is 0, this is minus 1.2. We want greater than, that means we want right side area, this area. Some net issue. Okay, no issues. Now understand, from symmetry point of view, even if we take this, that will be same. Even if we draw a diagram and take positive 1.2 and then take left side area, that is going to be same, right? Because the diagrams are symmetric. So what we'll do is, instead of z is greater than or equal to minus 1.2, we'll write it as probability that z is less than or equal to positive 1.2. And now we can directly go through the table, right? Because less than or equal to positive 1.2 means what? Less than this 1.2. So left side. So that will be, we can look it up from the table, 1.2. So 1.20 we'll have to see. 0.3849. 0.3849 plus 0.5, that is 0.8849. Check if everyone has got this. 0.8849. If you understand these four, then you can calculate everything. I'll summarize this now. But if you understand these four, you can calculate everything. Okay, let's see how. If you have probability that x is less than a positive number, let's say that a is a positive number, then what you do? You look it up from table. That is correct, Yashodan. Then you look it up from table directly. If you have probability that x is greater than or equal to a, then what you do? You write it as 1 minus probability that x is less than or equal to a, and then you look this up from table, because that is same as above, right? Same as above. Third case, let's say you have probability that x is less than or equal to minus negative number. Then what we do is we change both the signs. We write it as probability that x is greater than or equal to positive a, which is the second case if you observe. So we convert it to 1 minus probability that x is less than or equal to a, and then we look it up from table because that is now first case. And fourth case will be probability that x is greater than or equal to negative number. So what do we do? Greater than or equal to negative number, we just convert both the signs, so that becomes less than or equal to positive number, and then we can directly look it up from table. Okay. So in any case, you have to arrive at this first situation. If you arrive at that first situation, then you can look it up from table. You can note this summary somewhere. Generally, obviously, table will not be asked in exam, but some part of the table might be given. We don't know. They might give some part of the table, so you should be ready for that. Is everyone clear up to this point? If yes, let's take one last case, then we'll proceed. If yes, let's take one last case, fifth case here. If ever they give it like this, probability that x is between a and b, okay, that might be positive or negative, then we always have to convert it as, because see, x is between a and b means what? Maybe there is a somewhere and maybe b somewhere. So what we'll do is, first we'll find probability of a, that is less than a, then we'll find probability of less than b, and then we'll subtract it. So we'll always convert it like this. How? Probability that x is less than or equal to b, that is the second number. Okay, I wrote this opposite. Minus probability that x is less than or equal to a, that is first number. Less than. Remember this always. This might be important. This might be useful in questions. Whenever you have x is between two numbers, take less than second number minus less than first number. That's it. Let's take an example of this. These 5 cases are the only cases possible. So let's take an example of this now. Let's say we want probability that x is between 38.5 and capital X and 55.2. Same data, mu is 50, sigma is 10. First of all, you can also try by yourself. I'll also try it on screen. So we'll write it as first probability that x is less than or equal to second number 55.2 minus probability that x is less than or equal to first number 38.5. Then we'll convert it to standard normal, that is probability that z is less than or equal to 55.2 minus 50 divided by 10, which is 0.52, minus probability that x is less than or equal to 38.5 minus 50 divided by 10, which is minus 1.15. This we can directly go to table. If you see above values, this we can directly go to table. Second one, we'll have to change the sign. Okay. First one, let's look it up from table. 0.52, how much is it from table? If I write in black color, it will be 0.5 and this 2. So 0.1985 plus 0.5, that is 0.6985. This is 0.6985 minus, now we'll have to change the sign, so it will become probability that x is greater than or equal to 1.15 and then 0.6985, minus, we'll have to write it as 1 minus probability that x is less than or equal to 1.15. Alright, and this we can look it up from table now. So that will be 0.6985 minus 1 and then minus plus. Let's see what is 1.15. 1.15 is 1.1 and 5, that is this 0.3749 plus 0.5, that is 0.8749. So final answer should be this 0.6985 minus 1 plus 0.8749, that is 0.5734. Let me know if anyone has any doubt in this. Go through it carefully and then let me know if you have any doubt in this. When everything is clear, then we'll go to next concept. That is next properties of normal distribution. This probability part is done. That's it. So if everything is clear, then we'll go to properties of normal distribution. Clear everyone? Go through it carefully and then let me know. Try by yourself carefully. Yes or no? Yes? Okay, good. Others, clear? Correct, Yashodan. That is good. If yes, let's go to next properties of normal distribution. Now, next few properties. First property, I think we wrote that its expected value is mu. Its variance is sigma square. Then we saw what is standard normal distribution. Now let's go to next property. Next property is that it follows all the conditions of continuous continuous random distribution, probability distribution. That means what? For every x, f of x is always greater than or equal to 0. And this we can see. F of x is greater than or equal to 0. This we can see because we know the formula of f of x is what? 1 upon sigma root 2 pi, right? Into e raised to minus x minus mu bracket square upon 2 sigma square. Obviously e is positive, that means this is positive. Sigma is positive always, and this is obviously positive, square root. So everything is positive, so this condition is satisfied. Second condition is that integration of f of x from lowest value, that is minus infinity to plus infinity, should be 1. We cannot prove this because we have not seen this advanced integration, but it is true. Okay, this is called as, it involves something like called as Gaussian integral, but that is okay. So that is fine. Next property is that it is always symmetric. I think we wrote this yesterday, but fine. Always symmetric. That means what? If it is always symmetric, that means its mean is equal to its median is equal to mode. We saw in statistics, if you remember, its mean, median and mode are equal since it is always symmetric. Okay. Next, sixth. It is biparametric. No need to write this now, but okay, biparametric. Technically, we will just write just like binomial and Poisson, that this is biparametric, one mu and other sigma square. Next is, now understand quartile deviation, or before quartile deviation, let's see quartiles. Quartiles, that is q1 and q2, q3. q2 is median, which is mu. q1 and q3 of a normal distribution are given by, any normal distribution are given by mu minus 0.675 sigma and mu plus 0.675 sigma. Okay, q1 and q3 is this. That means its quartile deviation becomes what? q3 minus q1. So that is mu plus 0.675 sigma minus mu minus minus plus 0.675 sigma upon 2, right? q3 minus q1 upon 2. So mu will be cancelled. 0.675 into 2 is 1.35. Sigma divided by 2, that is 0.675 sigma. Clear to everyone? Then its mean deviation about mean, median, mode, because all are same. Mean deviation about mean, median, mode is approximately 0.8 sigma. Okay, it is not actually 0.8, it is, let me tell you, it is actually sigma root 2 by pi. Okay, but if you check this root 2 by pi, that is 2 divided by 3.1415926 something and square root, that comes to 0.7978 something. So we take it approximately from exam point of view as 0.8 sigma. Approximately you have to take it as 0.8 sigma. that is mean deviation of normal distribution. Is everyone clear up to this point? 3 wali means Misbah. Property third. Misbah, can you repeat like which one you are talking about? Then I'll explain. No issues. Okay. Then next, till then, let's go to next. 9. Property. Points of inflection. Points of inflection, or you can write inflection also. That is the points at which the normal distribution curve changes its curvature. That is, it becomes from convex to concave, concave to convex. Okay, that is, it changes its curvature. Because if you understand, this first part is like this, whereas the second part is like this, right? So there is a point at which this changes, which are called as points of inflection on this side and on this side. 2 points of inflection are this is mu minus sigma and this is mu plus sigma. Clear everyone? But third wali means, third wali is just standard normal distribution, means what? Whatever we discussed right now above. So I was just saying that standard normal distribution means nothing but normal distribution with parameters 0 and 1. That's what I wanted to say. Is everyone clear up to this point? These are points of inflection, mu minus sigma and mu plus sigma. Misbah, let me know if you are clear. Everyone else, let me know if you are clear up to this point. If yes, let's go to next part. Now, if we draw normal distribution curve, and if we go here mu plus 3 sigma, and on this side if we go mu minus 3 sigma, then the area between mu plus 3 sigma and mu minus 3 sigma, that is probability that x is between mu minus 3 sigma and mu plus 3 sigma is 99.73%. This you have to remember. If you actually check it from table, it comes to 99.74 or 72, I guess, but as per module you have to remember this number 99.73. you have to remember it, because if a direct question comes from that, it will be helpful. What does it say? That 99%, 99.73% probability is within this area. That means the outside area has very less probability, right? Very less, that means how much? That two-sided outside area together has only 0.27% probability, which is nothing. Misbah, fourth wala. This is PDF, right, of normal distribution, Misbah. In that, this is positive. This root will obviously be positive. E is positive, that means e raised to anything will also be positive. If everything is positive, that means this property is satisfied. And second property is that its integration should be 1. That we cannot prove, like I said, but for now let's note that it is satisfied. Okay, because we have not seen advanced integration which can do that. Clear, Misbah? Misbah, is it clear? Yes, no? Everyone else, is it clear? If yes, let's go to last property of this. Additive property of normal distribution. Understand carefully. Let's say x follows normal distribution with parameters mu1 sigma 1 square. Y follows normal distribution with parameters mu2 sigma 2 square. Then x plus y will follow normal distribution with parameters mu1 plus mu2 comma sigma 1 square plus sigma 2 square. That is just addition of this. Now there is a scope of mistake in this, I'll tell you where. Clear everyone? Okay, good. Let's take an example of this. Let's say x follows normal distribution with parameters 5, 16. Y follows normal distribution with parameters 4, 25. Or let's say 3, 20. And we are asked probability that x plus y is less than equal to 8. X plus y is less than equal to 8. How to do that? Concentrate now. X plus y will follow normal distribution with sum of this, right? 5 plus 3, 8, and okay, no, let's not take this as 8, let's make it 10, and 16 plus 25, which is what? 16 plus 25, 41. That means let's call this as z, or not z, let's call it as maybe w. That means we want probability that this w is less than equal to 10. So let's convert it to standard normal. W minus mu upon sigma, that will be 10 minus mu, that is 8. This is new mean now. Upon sigma is not 41, sigma is root 41. Okay, 41 is sigma square. So it will give us probability that z is less than equal to 10 minus 8 divided by 41 square root 0.31. This we can look up from table. 0.31, 0.3 and 1, that is this. 0.1217 plus 0.5, that is 0.6217. That will be the final answer. Again, let me know if everyone has understood this additive property. Is this additive property clear to everyone? I'll wait for a minute, tell me till then we can go to questions. If this additive property is clear to everyone, then let's go to questions. Only the important ones from solved. Clear? Okay, good. Fine, let's see one more property which is not directly given in module, but that is also important. 12th. Okay, we'll not use this anywhere, but see, binomial distribution can also be approximated using normal distribution. When? If n is very large and p is moderate, that is around 0.5, because then it is symmetric, right? P is moderate and n is very large, then we can approximate it using normal distribution. Okay. Because if we see, like, you can check also, maybe let's try to do it here if possible. Let's see. No. That one does not work, which we saw that day. Fine. Let's try to take n as very high now. Let's try to take n as 2000 if this works. Let's see. I mean, if this page is able to calculate it. Okay, it is not able to show it. Fine. Let me try 200. No. Fine. See, you can try. I have it on my phone. I have an app on my phone which can do that. But it will be difficult to do it here. But just understand one thing, that if n becomes very high, then those bars, okay, that those bars of binomial distribution are very close together, okay, and it nearly forms a frequency curve like normal distribution, okay. So it nearly starts looking like normal distribution. That is why it can be approximated. I mean, it shows that it can be approximated using normal distribution. Similarly, in Poisson distribution, if m is very high, that is if m tends to infinity, then that can also be approximated using normal distribution. You should remember this for MCQ point of view, not for calculation, because in calculation we'll never do this. Okay, but in these two cases binomial can be approximated and Poisson can also be approximated by normal distribution. Now let's go to actual questions from module. So let's see solved examples. Exercise I have already uploaded. I am already uploading in separate questions, separate videos. So let's not go through that. We'll see solved examples, the difficult ones, and then we'll be done with this. Okay. So let's come to normal distribution. The simple ones will not solve. 20 is okay. You can do it. Or this one, let's see, 21, 20. Fine. Let's see this one, 20. For a random variable x, the probability density function is given as this. Identify the distribution and find its mean and variance. How do you solve such kind of questions? See, we know that for normal distribution, the PDF is 1 upon sigma root 2 pi into e raised to minus of x minus mu bracket square upon 2 sigma square, right? So let's try to rearrange it like this. We have only root pi here. That means, can I write it like this? Let's write root 2 pi and let's write 1 by root 2 outside. That means root 2 will be cancelled and anyway root pi will remain, right? So I'm not changing anything. And e raised to, we have minus of x minus 4 bracket square, that is okay. But can I write it as 2 into 1 by 2? Because 2 into 1 by 2 is 1, that means again I'm not changing anything, right? And now if we compare, can I say this sigma matches with 1 by root 2? So sigma is 1 by root 2. And this mu matches with this 4. That means mu is 4. You can also check this. This can be written as root of half bracket square. So it will be same. So this will be sigma and this will be mu. So what you have to do is just compare. Just write your normal PDF and just try to compare what should have been here, so that this will be 2 root sigma root 2 pi. Got it, everyone? Such question is also there in exercise. You can solve it. It is simple. But just rearrangement is you have to do carefully. Something you have to do carefully. Don't make mistake in that. That was simple one. 21 simple. Let's ignore. 22 let's ignore. 23 let's try. X is a standard normal variable such that probability that x is between 0 and b. Standard normal variable means what? We have this. Okay, this area is given to us as A. Now they are asking what is the value of probability of absolute value of x is greater than equal to b. Absolute value of x is greater than equal to b. Absolute value of x is greater than equal to b means what? Positive value of x should be greater than b. That means x can be, let's say this b is 4. Let's say this b is 4. So then x can be 4, 5, 6, 7 and so on. Or x can also be minus 4, minus 5, minus 6 and so on. Because then its absolute value is still greater than 4, right? That means, how do we interpret this? Probability that absolute value of x is greater than equal to b means either x can be less than minus b or x can be greater than b. Either it can be less than minus b, that is minus 4, minus 5, minus 6 and so on, or it can be greater than b, that is 4, 5, 6 and so on. That means what we want is this area. X is less than equal to minus b means less than minus b, that is this area, or x is greater than equal to b means this area. So we want red colored area in total. Now we know that this is A, obviously this is also A, and total is 1. So answer of our red colored area will be what? 1 minus this A minus this A. That is 1 minus 2. Okay. Let me know if everyone is with me till this point. If yes, then only we'll proceed to next one. Let me know if everyone is with me till this point, because next one or two questions are going to be a bit complicated, so you'll have to concentrate a lot. Sorry. Let me know, everyone. Is this clear? Yes? Okay, good. Yes, fine. Fine. Then let's go to next one. This is okay. This is good one. Let's try it because it has something with given. They are saying that X follows normal distribution with mean as 120 and standard deviation as 40, so 40 square. What is probability that X is less than or equal to 150 given X is greater than 120? Let's use the formula which we used in previous lecture for binomial and Poisson. Probability that X is less than or equal to 150 and intersection means and X is greater than 120 divided by probability that X is greater than 120. That's it, right? Less than 150 and greater than 120 means what? Can I say between 120 and 150? Understand? It is less than 150 and greater than 120 means what? It is between 120 and 150. So we can just write it as probability that X is between 120 and 150 divided by probability that X is greater than 120. Let's use that rule A and B. So that will be probability that X is less than 150 minus probability that X is less than 120 divided by probability that X is greater than 120. Now we can convert everything to standard normal. We'll have to subtract 120 and divide by 40. So probability that Z is 150 minus 120 divided by 40. That is 0.75 minus, this will be actually 0, right? And this actually, if you see, this 120 is mean, so we can directly write it as half because 120 is mean, so greater than mean means half probability will be there. Clear, everyone? So now we can try this. They have already given the data. Actually they are saying that from 0 to 0.75 the answer is 0.2734, so our probability will be 0.7734, right? So it will be 0.7734 by adding 0.5 minus, this is also half because 0 is the mean, divided by half. So the answer should be 0.7734 minus half divided by half, that is 0.5468. Okay, you should be able to solve quickly, fast. Let me know if everyone has understood. Again, got it? Less than 0.75, that is given to us, and less than 0 means that is mean, so that will be exactly 0.5 half, right? So that will be the answer 0.5468. Let me know if everyone has got it. Till then, let's see which next question to solve. This is a good one. Let's solve this. Got it, everyone? Let's solve this. 26th. Now, ideally, they should not have given this. Okay, they should not have given this because of that question makes no sense, because anyone can solve it then. So let's ignore this and then let's try to solve it. X is normal variable with mean 25 SD 10. That means X follows normal distribution with 25 and 10 square. Find value of B such that probability of the interval 25 comma B, that is probability that X is between 25 and B, is 0.4772. Okay, how do we do that? Concentrate now. See, let's convert this to standard normal distribution first. So it will be 25 minus 25, 0, 0 upon 10 is 0, is less than equal to x, is less than equal to b minus 25 by 10. That is equal to 0.477. If we draw the diagram, then this is b minus 25 by 10. So it is just this part. And we can already get this part from table directly, right? So in table, let's check which value is 0.4772. They have given it directly, so it does not make sense. The answer is 2. We know that. I mean, this is 2. But let's ignore it for a moment and let's try to find this value from the table. Now we'll have to find in opposite way. This is probability. So 0.4772 we'll have to search in the table where they have given 0.4772. Now I'll have to go to the table. Wait. In the table, we'll have to search where they have given 0.4772. Okay, if you observe, it is here because we know the answer 0.4772. So that will be 2.00. So the answer is going to be 2.00. That means wait. That means this is 2.00, right? That means b minus 25 by 10 is 2. That means b minus 25 is 20. So b is 45. Let me know if everyone has got this. Okay, Risturaj, if you want, you can watch the lecture later from beginning. No issues. Tell me if everyone has got this. If yes, let's proceed to next one. We are just taking quickly, but understand this. If you have any doubt, you can ask me anytime, no issues. $27 is easy, will not solve it. Got it? Okay, good. 28 is a good one. Let's solve that. 29 is a very good one. So let's solve that. Okay. Especially 28 and 29 will have to solve. Others are fine. Okay. This 31 maybe we'll try. Let's see. 28. Let's try it. The distribution of wages of a group of workers is known to be normal with mean 500 and SD 100. So X follows normal distribution with 500 and 100 square. Got it? Okay, good. Rishuraj, Vaibhavi, Sukanya. Okay, fine. Others, let me know. Akash, Yashodan. Then, if wages of 100 workers in the group are less than 430, that means, what is the total number in the group? That means, probability that wages are less than 430 is 100 out of total, right? Whatever is total workers, let's say total workers are 200, then that means probability is half because half of the workers are less than 430, right? So probability that X is less than 430 is 100 by total. So now we can find that N. How we can find that N? Let's try it. Let's convert this to Z is less than equal to 430 minus 500 divided by 100 minus 0.7 is equal to 100 by N. For negative, we'll have to change the sign. So it will become positive and greater than equal to. Again, we'll have to subtract it from 1 because we want to change the sign. So that will be Z is less than equal to, 0.7. And this we can find from the table now. Okay. See if everyone has understood this. And if yes, find this from table. 0.7. 0.7. Okay, no, I'll have to go to the table again now. Is it given in the question? No. Can someone tell me this value? 0.7. After adding 0.5. After adding half, can someone tell me this value so that I don't have to go to the table again? Anyone? I'll wait. Can anyone tell me value of that from table after adding 0.5? This 100 by n, why did we take it? Because this is just total 100 out of total, right? That is what gives us probability. Anyone? 0.7. How much? अब तक आना चाहिए था फास्ट. What happened? Or will I have to look it up? Fine. Point 7 is 0.2580. Okay, 0.758. I think I got the comments late. That is okay. Fine. So 0.758 is correct. 0.258 plus 0.5. That is 0.758. So 1 minus 0.758 is 0.242 is equal to 100 by n. So n is 100 upon 0.242, which is 413.22. So approximately 413. Because number of workers cannot be in decimal points. So 0.413. Sorry, 413. Correct, Yashodan. Correct, Akar Sukanya. Fine. Has everyone got this? Correct, Vaibhavi. Okay. If yes, got it, everyone? If yes, last question 29th, which is very important. You can mark it because this is a question of binomial plus normal. Okay, we'll have to apply some binomial concepts first, and then we'll have to apply some normal concepts, normal distribution concepts. So let's read it carefully now. Mean height of 2000 students at a certain college is 165 centimeters and standard deviation is 9 centimeters. Okay, that means x follows normal distribution parameter 165 and 9 square. What is probability that in a group of 5 students, 3 or more students would have height more than 174 centimeters? In group of 5 students, 3 or more will have height more than 1 centimeter, 174 centimeter. This is a question of binomial, but in binomial we have n as 5, x as 3, but we don't have probability of success. That is what we have to find using normal distribution. Okay, so first, okay, I wrote this opposite. First we have to use normal distribution, then we'll use binomial distribution. How? Concentrate. We want students having height more than 174 centimeter. We don't know what is probability of having height more than 174, but we can find it because we have normal distribution parameters given to us, mu and sigma square. Right, so let's try to find this probability of height more than 174. So let's convert it to standard normal. Z will be greater than or equal to 174 minus 165 divided by 9, which is 1. So that will be 1 minus probability that Z is less than or equal to 1. For 1, I think we calculated it here. Let me check. Probability of 1 was 0.8413. So 1 minus 0.8413. That is 0.1587. That is the answer to first half of the question. What is probability that height will be greater than 174? Okay, 15.87% or 1.1587, that is 15.87%. 87% if we want. Now let's take binomial distribution. Let's say that y follows binomial distribution with parameter 5 students, because we want 3 out of 5 students, right? And probability of success as 0.1587. And now we want 3 or more students to have height of more than 174. That means we want 3 or more successes. Probability that y is greater than equal to 3. 3 or more successes means what? Either 3 successes or 4 successes or 5 successes, because n is 5. So how can we calculate it? 5c3 into 0.1587 into 3 raised to 3 into what is q? 1 minus 0.1587 is 0.8413 square plus 5c4, 5c4 is 5 into 0.1587 raised to 4 into 0.8413 raised to 1, or 5c5 is 1 into 0.1587 raised to 5. Let's calculate on calculator. 5c3 first of all is 10. Okay. 0.1587 cube into 0.8413 into 0.8413 into 10 m plus 0.1587 raised to 4 into 0.8413 into 5 m plus 0.1587 raised to 5 m plus. If you press MRC, I think you are getting answer as 0.03105. Check if everyone is getting this, yes or no. It was a complicated question. First we used normal distribution, then we took that probability as P, probability of success, and then we used binomial distribution. Go through it carefully and then let me know if it is clear to everyone. So that was a tricky question. Clear everyone? Because if yes, then we'll stop here for today. Correct Akash, good. Correct Akash, good. Clear, good. Sukanya, Yashodan. Okay. Now for today we'll stop here. This concludes theoretical distribution. Now if you guys want any other chapter to be revised, let me know on the discussion group of Telegram channel. Okay, so the MCQ channel on Telegram, which I hope everyone has joined. So in the discussion group of that channel, you can let me know if you want any other chapter, so we can start its revision. Okay, otherwise I'll decide some chapter randomly which might be useful. Okay, but if you have anything specifically, you can let me know, and I'll tell you what will be the schedule of next lectures. Maybe tomorrow or maybe after 3-4 days break. Okay, so I'll let you know on the group. Fine, so let's stop here for today. Okay, so bye everyone and good night. Okay, so good night everyone. I think it is lagging again. Oh, fine. Yes, bye, good night. Yes, good night.